and we will get the slideshow opened from the current slide. All right, first I want to know, any questions from anything we've covered so far? If not, we're continuing in Chapter 6, Quadratic Equations and Inequalities, and 6.2 is talking specifically about quadratic equations. We're going to solve quadratic equations by factoring. I can almost hear you say, what's new here? Okay, we've been doing that. So this is sort of a review. But we'll solve quadratic equations of another form. If we can express this as x squared is equal to a, then we can solve that way too. You have to be just a little more careful with it, but that is a technique. And we'll solve some problems pertaining to right triangles and 30, 60, 90 triangles, which are quadratic equations. Now, again, we run into this. The advantage of doing Chapter 6 after Chapter 3 is we're talking about factoring, we're talking about solving quadratic equations and higher order equations. That's what we're dealing with here. The disadvantage of jumping to Chapter 6 is we're skipping 4 and 5, which covers, for instance, rational or irrational numbers. So we're going to, when we run into them, we'll just sort of gloss over them. You're not going to be responsible for them yet. Once we do chapter, I believe it's 4, then you're responsible for these. I'll get you a heads up on them so it'll be easier when we get there, but that's the disadvantage of jumping ahead to 6. But it seemed like the advantages outweigh the disadvantages. All right, and Peyton's here. Okay, anyone else come in since the call roll? Okay. A second degree equation in one variable has what? Exponent of 2 and only 2. No higher power. Second degree equation, exponent of 2. Does it have an exponent of 2? Not a second degree equation. It's a linear equation. It's less than that. Such equations are also called quadratic equations. I don't know about you, but when I see the term quadratic, I think 4 something, quarts, quads, stuff. But it's not. Quadratic equation. 2 solutions generally. 2 second degree. These are the following are examples of quadratic equation. Is that a quadratic equation? Pardon me? Why not? Okay. The thing is, the maximum exponent is 2. The only exponent is 2. That is a quadratic equation. Now, sure, they got the 36 on the wrong side, but we'll learn to use it there or move it over. Is that a quadratic equation? Yes, maximum exponent of 2. We've solved them like that. Is this a quadratic equation? Yes, it is. Maximum exponent is 2. Doesn't matter what the lesser ones are. Those are quadratic equations. Now, quadratic equation in the variable x can also be defined as any equation that is written in this form. And we call this the standard form for a quadratic equation. We've been doing this pretty much. If you think back, before we ever tried to factor, what did we do? Get everything on one side, 0 on the other. We were doing this all along without saying it. Now, what does A, B, and C stand for? What do we call those? The coefficients of your variable. The variable is x. A, B, and C are coefficients of x. Now, are there any restrictions of what A, B, and C can be? Do they have to be whole numbers, integers, fractions, decimals? There's really no restriction on any of these except for one restriction. If this is a quadratic equation, A cannot equal 0. Why could A not be 0? Why do we pick that out? If A was equal to 0, what kind of equation is that? A linear. It's no longer quadratic because it doesn't have a quadratic term. So that makes it a linear equation. So for this quadratic equation, A can be any number in the world, positive, negative, fraction, decimal, rational, irrational, but it can't be 0, okay? B, C, they could be anything, including 0, but A cannot be 0. So A, B, and C are any real numbers as long as A is not 0. The form, I've already said that, is called the standard form of a quadratic equation. We're going to really be using this in a couple sections, okay? Right now, it's important. Later, it'll be essential, okay? We have solved quadratic equations. The term quadratic was not used at the time, though I think I was saying it all the time, by factoring, okay? If this thing is factorable, in other words, you set up your two possible binomial factors, and you unfoil it, that kind of stuff. Now, I really don't like this. If they're going to have a slide here with A, B, C being constants or coefficients, then down here don't have A, B. Make it something else. PQ or anything else. This A and B are not the same thing. It has nothing to do with this, okay? But if we have an expression, once you factor this, that something times something else, like we have with binomial times binomial, is equal to 0, we know that's true if and only if A is equal to 0 or B is equal to 0. These A's and B's have nothing to do with those A's and B's, so don't let them confuse you. I think that was poor choice on their part. So let's do one. Based on what we already know how to do, can we solve this one? Let me get my pen set up. Okay. If that's, how would we go about solving it? Give me a guess. Factoring, very good. Before we ever attempt to factor, what you got to make sure it is? What form does it need to be in? Standard form. Well, it's already a quadratic equation. It needs to be in standard form with everything on the left or one side or the other, 0 on the right or just the other side. But this one already comes that way. So what would be our next step if we're going to try to factor? Okay, I don't know if I know exactly what you mean there. Okay, right. We unfoil. Okay, that's what I call it anyway. It's a dumb name. 3n squared. What's the only possible factorization of 3n squared? 3n times n. Very good. Where do we look next? Sign of the last term. What is it? Negative. What does that tell you about these two signs? They've got to be different. So what do you want to put them? Say again? A plus and a minus. Let's try it that way. Okay? And then we look at the last term, and what is, it's 5. What's the only possible factorization for 5? 1 and 5. Actually, 5 and 1 is also a possible factorization, but we'll put 1 and 5 because that's what you said first. Okay, let's see if we factored it right. We were just guessing. This is called the trial and error method. So you expect a few errors every now and then, okay? Not on your final answers, but on the getting there, okay? So let's see if we got it right. Pull it. 3n times n? 3n squared. That part's okay. Outer then is minus 15n plus n. That gives you negative 14n. What's wrong? The sign's wrong. The number's right, but the sign's wrong. So what do? Change signs. Okay, so let's change this sign to the minus and this sign to the plus. I don't think I really have to do it again, but let's just for completeness sake do it. Check again. 3n squared plus 15n minus n, that makes plus 14n minus 5. Yes, it works. What do we do now? That was just to set it up to get our solution. Say again? Okay, we have two things, A and B, that we multiply to be 0. So that means either the first one's 0, 3n minus 1 equals 0, or n plus 5 is equal to 0. So let's solve each of those. What do we do on the first one? Add 1 to both sides. That gives us what? 3n equal 1. Now what? Divide by 3, and that gives us n equal 1/3. There's one possible solution. The other is subtract 5 from both sides, and that gives you n equal -5. All right, now, frankly, I like to check it because I don't like making errors. I make lots of them, but I try to catch them if I can. The first one's a little messy, but not too bad. What happens if we square 1/3? What does that give you? Squaring n, 1/9. Okay, so you have 3 times 1/9. And what is 3 times 1/9? Well, we'll get there in a minute. Plus, and 14 times 1/3 would be what? 14 times 1/3 would be 14/3. Okay, very good. Minus 5. The question is that equal to 0? We don't know yet. What's 3 times 1/3? 3 times 1/9? 1/3. Okay? Plus 14/3. Now, what's wrong with this thing? Everything's in thirds except the 5. How many thirds is 5? How many? How many thirds is 5? Okay, I think in terms of food. Okay, so my wife made 5 loaves of pound cake. Okay, yes, okay. 5 loaves of pound cake. And she cut every one into thirds. How many thirds do I have? Okay. I don't like the way you count pound cake. I think more than that. Okay. Say again? 5. Okay. No, we had 5 pound cakes. She cut each one of them into thirds. 15. She had 15 thirds of a pound cake, right? Because 3 will go into 15. 5. Okay. So this will be minus, if I could write, 15 thirds. Is that equal to 0? Okay. Wait. 1/3 plus 14 thirds is 15 thirds. Minus 15 thirds is 0. Yes. Okay. Maybe checking isn't such a good idea. Okay. No. Y'all had the right answer, but don't blow it on the checking. The next one shouldn't be quite so bad. Plugging in a -5. 3 times -5 squared plus 14 times a -5 minus 5 equals 0. That's the question, is it? What is -5 squared? 25. So you have 3 times 25. What's plus 14 times -5? First, tell me the sign. Negative. 70. Very good. Minus 5. Is that equal to 0? What is 3 times 25? 75 minus 70 minus 5. Is that equal to 0? Yes. All right. All right. You don't want me to get right answers, do you? Okay. Yes, because this is plus 75. These could add to be minus 75. That together adds to 0. I should have done that right here to make it easier to see. All right. So we checked it. Both of them work. We found the solution. Let's clear all that out. Any questions on that before I move on? Does that make sense? Okay. I'll erase all the ink, and we'll go on. And they write it again. What a good first step. Okay? And then they factor it. Okay? Because they had it equal to 0. They had it in standard form. You could try to factor. They did factor correctly, by the way, too. And then they set each of the factors equal to 0 because of zero product principle. If the product of 2 entities equals 0, one or the other has to be 0. Okay? And when they did that, we went solve for n. On the first side, we got 3 n's equal to 1. Second side, the right-hand portion of the board, subtracting 5 from both sides, said was n equal to -5, which was a correct A solution. and then dividing that. So there's your solution set. Shame on them, they didn't check. Okay, but they were pretty confident because they watched what we were doing. They knew you got it right. So -5 and 1/3. Any questions on that? Always a good idea to check, especially if you have time. All right, that was example 1. They're skipping example 2, and for good reason. Do you want to see that one now while we're doing it, or want to wait until you're further along? Oh, we did it. That's right, you did. Okay. All right. So then we're ready for solving quadratic equations of a new form, x squared equal a. Now, what's different about this form? What's the last form we were using? Standard form. Is that standard form? No, because this is not 0. If you subtract a from both sides, yes, it's 0. Okay? Then the right-hand side would be 0. But that's not standard form. But don't throw it away until you give it a good look. Okay? And if x squared, now again, we're getting into radicals here, and we're not going to really do much with them. I'm just going to show them to you on the slides. But let's consider quadratic equations of the form x squared is equal to a, where x is the variable and a is any real number. We can solve that then if we subtract a from both sides and get it in standard form. Okay, that's what I was saying before. Now, here's a little trick. They say a is any real number, meaning it doesn't have to be a perfect square. It could be a perfect square, but it doesn't have to be. So what they're going to do is make it a square. Well, what's a number that a is the square of? What undoes a square? A square root. So that would be a minus the square root of a squared. Because if you square the square root of a, you get a. So that's the same thing. That means you have x minus the square root of a times x plus the square root of a is equal to 0. Then you can solve each one of these separately, and you get x equal the square root of a, or x equal negative square root of a. Now, we haven't done square roots. Don't sweat them now. But if this a was a perfect square, name me a perfect square. 4. If that was 4, then this would be x equal square root of 4, which is 2, or x equal negative square root of 4. And what's square root of 4? 2. So that would be x equal 2 or x equal negative 2. But we would have seen that right off the top by x minus 4. We'd have just factored this as x plus 2 times x minus 2. That's what we were doing before. We just didn't realize well, I guess you did realize we were taking square roots. But now we're saying this works for any number a. It's just now we have plus square root of a and minus square root of a. Okay? We haven't dealt with radicals yet, so don't sweat them. Okay? These solutions are, we said that, we can state that result as a general property using this for any real number a. X squared equal to a, if and only if x equal plus square root of a or x equal minus square root of a. The statement that can also be written, and this is the shorthand, x equal plus or minus the square root of a. In fact, our other answer could have been written x equal plus or minus 2. That's another way to write that. Saves a little bit of ink or pencil, okay? We're real stingy, aren't we? Okay. Now, that property, along with our knowledge of square roots, makes it very easy to solve quadratic equations that are of this form, even when the a is not factorable. In other words, not a perfect square. Okay? We'll wait and do that some more later. Do you want to see how to do this one? This isn't necessary. It's not something you're responsible for yet. When we do the next chapter, you will be responsible. No, I think it's the chapter after next. Next chapter is rational expression. Then we have radical expressions. Okay? What does the rule tell us? Say again? You could do that, or they just gave you that new rule says take the square root of both sides, right? That's not what they called it, but that's what we were doing, right? Square root of x squared is x, And this would be, but when you do this, this is the thing you have to remember. You always put a plus or a minus the square root of 45. Yeah, you have to put the square root sign, but whenever you're taking the square root of both sides of an equation, the variable we usually don't put the plus or minus, the number we do. Because remember, if we're doing x squared equal 4, the answers are plus or minus 2, the way we used to do it. So we have to do plus or minus the square root of 45. Now, or you could have written them out separately. Now, this is something we haven't done yet, but I'm going to give you a little heads up of what's coming in 2 chapters, okay? Now, anytime you see a radical square root sign, what you can do is there's 3 rules that we'll need to follow. I'm only going to give you the first rule right now because it's the only one that applies here, okay? You look at this number 45 and you try to see if there is a perfect square hiding somewhere in 45 in the multiplication sense. Remember what our perfect squares are? 0 squared is 0. That's certainly no 0 in there. 1 squared is 1. Well, 1's everywhere, so we don't worry about that one. 2 squared is 4. No 4 in 45. Okay, no. And as a factor of 45. Okay. 3 squared is 9 in 45? Yes, it is. So we will factor that out. That would be 9 times 5. Perfect. Okay. Again, you're not responsible for this yet, but this is just what's going to be coming. Now, here's another rule. We can write this as plus or minus the square root of 9 times the square root of 5. Okay, you only need the plus or minus out in front. Okay. Now, what that says is the square root or radical of a product is the product of the radicals. Does that make sense? Now, what did you tell me square root of 9 is? Okay, so that is plus or minus 3 times root 5. Or you could write it x equal 3 root 5 or x equal minus 3 root 5. So again, you're not responsible for this yet, but this is just looking ahead. We'll get there later. Okay? Have y'all done radicals before? You did? All right, good. Okay. I didn't remember if that was done in 098 or not. Okay, you did it in high school, huh? Okay. Good. I'm glad y'all remembered it. This will just show how they do it. Same way we did. First step, they didn't write it out there. Take the square root of both sides. Square root of x squared is x. Square root of 45, square root of 45. Remembering, anytime you take square root, you have to put a plus or minus in front. So plus or minus the square root of 45. And then they didn't, they wrote the steps over there, but just wrote the answer here. There's your solution set. You could write it that way, or minus 3 root 5, comma, 3 root 5. Either way. Make sense? See, they broke it down the same way we did. All right. Let's see. That was example 3, I believe. Let's go back and do example 4. Just a little bit. You're not going to see one like this on a test. I hope you won't anyway, but let's see. Solve this. X squared is equal to negative 9. What do you think? Depends on where you're living, right? If you're living in the real number system, what's your answer? Okay. All right. Would either 3 or negative 3 work? If x is equal to 3 squared, and what do you get? 9. Positive. What if x is equal to negative 3 squared? 9. So neither one of those are answers to this. So in the real number system, there is no answer. So for us right now, no solution. Okay? Remember what we did in 6.1? Just ran through it real quickly. We introduced that square root of negative 1 is equal to I. You could write it in the complex number system, But if we're living in the real number system, no solution. Okay? That's all I wanted to say about that one. Right now, that's an acceptable answer. Okay? How about the next one? Okay? You're not responsible for this one either, but let me at least show it to you. 7n squared is equal to 12. What would you do first? Say again? Divide by 7. Okay, he's going, Chris is going this route. He's saying, hey, I want to get it into the squared mode. Okay, well, that mode was x squared is equal to some number, not 7x squared, so he divided by 7, got rid of that, and that gave him n squared is equal to 12 over 7. All right, what would be the next step? How do you undo a square? Square root. So this would be square root of n squared is n. And how about the right-hand side? Plus or minus, excellent, the square root of 12 over 7. Okay, it's time for the second rule. I was hoping we wouldn't maybe go here, but let's just do it. All right, the first, we try to find any perfect squares hiding in the radical. We're going to have one, but we're going to deal with that in a minute. The second is, and these two are really related, the next two, you don't want any denominators in the radical, nor do you want radicals in the denominator, okay? And frankly, I would change this to a form that has radicals in the denominator, even though that's not what we want. Just like the radical of a product is the product of the radicals, so is a radical of the quotient of the radical. So I think I would also write this as, just because it's going to be easy to work with, can't forget your plus or minus, the square root of 12 over the square root of 7. Okay, the reason I did that, even though this violated the second rule, you can't have denominators in the radical, this one violates the third rule, you can't have radicals in the denominator. We'll get to that in a second. But, what do you notice we can do here? What does 12 have? Say again? Yes, you can take out a 4. So this is going to be plus or minus the square root of 4 times the square root of 3. Excellent. Divided by, now, we don't want radicals in our denominator. So it's something we can do to get rid of the radical in the denominator. And by the way, does anyone want to know the reason we don't want radicals in the denominator? Y'all grew up with calculators, didn't you? And computers. Okay? And there is no problem in the world of plugging into the computer the square root of 12 over 7. And you get an answer, right? But back in the old days, like when I was in school, the really old days, okay, how you had to deal with this, we didn't have calculators. We couldn't just punch in the number. We had to go to a table, or we had to do it by hand. Hopefully you'd find a table. And that table would probably give you 4 to 6 or 8 digits. The trouble about the square root of 7, it's an, anyone know what kind of number that is? Say again? Okay, it's called, say again? Okay, 7 is, but square root of 7 is totally irrational. Okay, it has nothing to do with gender. No, I didn't say that. Okay, it's an irrational number. What does that mean? That means you cannot write it as a ratio of 2 integers. Can't do it. But in decimal form, that means you can't write it. You can write it as a decimal number, but you'll never end the decimal. That's called the terminating decimal. Or you never repeat any pattern. Any pattern. You can go forever and ever and ever and ever, and you'll never reach your pattern. Ever. Same thing's true with the square root of 3. In fact, most square roots are irrational numbers. Square root of 2, square root of 3, square root of 5, square root of 6, square root of 7, square root of 8, square root of 10. Most of them are irrational. Just a few every now and then you'll find that's a rational number. Okay? So this one is not. This one's not that. You know what? We don't worry about this. But if we were dividing this, if someone's got a calculator, we're going to cheat a little bit here. Find out what the square root of 7 is. Anyone done it? Second? A little louder. 2.6, is that all? 4.5? 7.5. Second? 1.311. 0.6 what? 4. Have you run out of digits yet? Huh? 591. Goodness, how long's your screen? 591. Is that the end? Okay, that's not really the end. That's as far as her computer goes. Okay? Now, if you were really dividing this, what you would do, whatever that numerator is, you'd have to divide by this. Well, that means on the outside, you'd have 2.64575, 1311, 06, 4591 into whatever this is. Now, whatever that is no problem. But how about dividing this into that? How you do that? You move the decimal that many places. Then you have to move this decimal that many places. And you would divide it by hand because you didn't have a calculator, right? That's not a pleasant sight, okay? Not an easy thing to do. So what we do, we want to rationalize the denominator, make that a rational number. Can anybody think of a way to do that? While I'm erasing, you think of a way, because I sure don't want to divide that way. Can anyone think of how you can make that square root of 7 a rational number? Okay? How do you undo a square root? Square it. And what does squaring mean? Multiply it by itself. Okay? Now, it looks like we just made it work. If you do that to the denominator, what have you got to do? Same thing to the numerator. It looks like we've made it worse, right? Except for this. You got your plus or minus. What's square root of 4? 2. And you can go back and put these back together. The square root of 21, right? But what's that denominator now? The square root of 49, which is 7. Guess what, team? I can divide by 7. It's not pretty, but I can do it. And whatever this number is here, and it goes on forever, that's a much easier division to do, right? And back when we had to divide things by hand, you never wanted a radical in the denominator. Nowadays, it really doesn't matter. Your computers, your calculators can handle it. But in the old days, that's how you wanted to do this problem. You see how much easier that would be than moving that decimal that many places and then trying to divide that big number into another huge number. Oh man, what a pain. This is still a little bit of a pain, but that would be pretty easy to do. Okay? Now, I want you to think about this for a minute. Okay? The atomic bomb. Do you think that was a pretty simple thing? No, nowhere close. In fact, they were having to solve equations no one had ever even thought of before. And they were needing to be pretty precise about it, wouldn't you think? Do you want to be off by a little bit, have it blow up a little bit too soon? I don't think so. Or to spend millions of dollars on it and then not have it work at all? No, you want to be very precise. So how in the world did they develop the atomic bomb before they had calculators or computers? What they had to do, they hired rooms full of mathematicians and physicists really high-power mathematicians and physicists and have a room like this, and they give them all the same problem with all these really hairy calculations in them, and so they solve this, and then get their answers and find the one that's most common and hope that was right. And then go back and see if they can find the errors in the other one, hope they had it right. And that's how they did it before the calculators. And you remember what that project was called? The Manhattan Project. And those people didn't know what they were solving for. They were just given these, and these were high-powered, probably PhDs, math and physics, master's math and physics, or really, really, really bright undergraduates in math and physics saying, work these things, and they had to do them by hand. And you better believe it, they got rid of all those radicals in the denominator by doing this kind of stuff. Okay, but we don't have to do that anymore, you lazy people. No, I mean, you fortunate people. Okay, so anyway, that's the only reason, I'm sorry, I spent way too much time on that. Here's one that we do need to do. So this is much more practical than those were. All right. 3n plus 1 squared is equal to 25. Okay? Now, if I wanted to take you back in time to earlier in this term, like maybe a week or two ago, and that was our problem, what was the only way we had to solve it? Anyone remember? You had to square this, square the binomial, get a trinomial there, move this to the other side, get it equal to 0, standard form, and then factor and try to solve it. Now that we have this new technique, x squared is equal to a, we have a new tool in our pocket, don't we? Because this is a perfect square, and what's even better? That's a perfect square. So what can we do? What's our technique? If you have a perfect square, how do you undo it? Take a square root of both sides. And what's the square root of that one and the square root of this one? What's the square root of 3 plus 1 quantity squared? What does the square root do? What does the square root do? It undoes the square. So what do we have left? 3n plus 1. And then what's on the right-hand side? Oh, well, you let me get away with something, didn't you? When I write this on the other side, what do I have to do? Plus or minus, why didn't someone correct me? Equal to, what's square root of 25? Plus or minus 5. Okay? This is where you get your two solutions. First solution is 3n plus 1 is equal to 5, or 3n plus 1 is equal to negative 5. Solve the first one. What do we do? Subtract 1 from both sides, and that gives us 3n is equal to, say again? Yeah, 4. Okay, good, okay. Then what? Divide by 3. And that gives us n is equal to 4/3. Or, right-hand equation. What do we do with it? Okay, subtract 1 from both sides. That gives us 3n, so that goes to 0, is equal to negative 6. Divide by 3, and that gives us n is equal to, say again? Negative 2 over 1, which is negative 2. Very good. Right? I know y'all want to check this, don't you? Sure you do, okay? All right. The original equation without the square roots in there, like the plus or minus in there. Okay. 3 times 4/3. What's that? 3 times 4/3. Say again? It's 4, yeah. 3 times 4/3. The 3's go out because they're dating. No, I'm sorry. That just leaves us a 4. Okay? That's what this is. 4 plus 1 is 5. 5 squared is 25. That one works. I think -2 will even be easier. 3 times -2 is? 3 times -2? -6 plus 1 is? -5 squared is? 25. You got it. So that one works too. And by the way, this one I said, let's check it. Anytime you take the square root of both sides of an equation, you better be checking. Because remember, you could have introduced an extraneous solution. So that was good to check them both because you really needed to. And if you look in the book, they got -2 and 4/3. Good for them. Okay? All right, how about this one? X minus 3 squared is equal to -10. What you think? How would you proceed? Second? The square root of both sides. Sounds like a capital idea to me. Square root of this. And if I do it on this side, what I better do? Plus or minus. Good for you. Okay. What's the square root of x minus 3 squared? X minus 3 is equal to plus or minus, and what's the square root of -10? Okay. Say again? Okay, you want to do a square root of a 2 and a 5. Where's the minus sign? Right, that inside too. Okay, fine. I'm happy with that. What are we going to do with that? Where are you living? Are you living in the real number system or complex number system? That's important here. Real number system. Well, guess what? Yeah, this is the only solution to this is complex. So therefore, if you're not living there, no real solutions. That's all you have to put. When you see something squared is equal to a negative number, stop right there and say, no real solutions. That is the correct answer. Okay? Since we're not doing complex numbers, I showed you how to do those, but I said we're not responsible for it. We're going to live in the real number system. Okay? If y'all don't mind the neighborhood, okay, then if you see a perfect square equal negative, no real solutions. There's your answer. Don't even have to write this step. Okay? Now, how about this one? This is no real solution. Okay, something like that. NRS. Okay, whatever that is. Okay. 3 times 2x minus 3 squared plus 8 is equal to 44. There's several ways to approach this. How would you like to do it? Turning the page is not an answer. Okay? How would you do this? Okay. Second? All right. Okay, I heard two things going on there. One was dealing with this, and I think you have to square it first, then distribute. But the other answer was get rid of everything else and leave the perfect square. You know, I'm lazy. Guess which way I like to do it? Let's leave the perfect square. Let's get rid of everything else, leave the perfect square. So you said subtract 8 from both sides. You can do it the other way. If you're a hard worker, you can still do this. But, you know, let's be lazy by all means. Minus 8 from both sides. And that gives us what? 3 times 2x minus 3 squared. That goes to 0 is equal to, what's this? 36. Next. divide by 3. I like it. And that gives us 2x, someone fell asleep. No, okay, 2x minus 3 squared is equal to, a little louder? Can't hear you? 12. Okay, very good. Now, I have another question for you. Same question. Where are you living? Okay, if you're living in the real number system, we got some work to do. But if you're living in the rational number system, okay, then we got it not. Because the square root of 12 is an irrational number. So you can say no rational solution to this. After we do chapter 5, we'll be having to do this. But until then, no rational solution. Or you can just leave it square root of 12. You can take square root of both sides. I'll go on and do that. And that would be 2x minus 3 equal, what did I better put here? Plus or minus the square root of 12. And you could leave it there if you wanted to. Here's how they want you to do it. Go on and solve for x. Well, I'm going to do two things. First, add 3 to both sides. Okay? But what I'm going to do, well, I should do it down there, but that would be 2x, this adds a 0, is equal to, I'm also going to do this, plus or minus, and 12 has in it a perfect square, the square root of what? 4 times 3, okay, plus 3, okay, so this will be 2x is equal to plus or minus 2 root 3 plus 3, and then we divide by 2. And that gives you x equal to, that goes out, plus or minus, and actually this 2 cancels one of those, so this is plus or minus the square root of 3 plus 3 halves. That's messy. We don't have to do that. We're not in the irrational system yet, so just say no rational solution. In other words, I'm not going to give you one like that if I can help it, but that's what you would do, okay?
No, we would stop on this side.
Yeah, actually, as soon as you see you can't do this, say no rational solution. But I'm going to try not to give you any like that until we get to chapter 5, and then you're going to be responsible for it. All right, but that's how they got their answer. Actually, they wrote it a little differently. They wrote it this way: x equal plus or minus 2 root 3 plus 3 over 2. Like I had it before, and that's, except they wrote the 3 in front, 3 plus or minus. In that, in other words, that's sort of a little more standard. 3 plus or minus 2 root 2 over 2. Doesn't matter, you're not responsible for that. All right, so let's move on to, these are all solutions for example 3. We passed that a long time ago. Solving problems pertaining to right triangles and 30, 60, 90, 30, 60, well, they are 90 triangles, okay? How much time we got? Okay? It's what? 9:05, 10 minutes. I want to tell a little dumb story, but it has nothing to do with math, so I'll skip it. Okay. So, sorry about that. Our work with radicals, which we haven't done yet, so don't worry about that, and the Pythagorean theorem, y'all know that? Remember that? Did we do that a little bit before? Okay, yeah. Okay. Form a basis for solving a variety of problems that pertain to right triangles. Okay? Here's one. A 50-foot rope hangs from the top of a flagpole. When the pull taut, meaning tightly, so it's just hanging there, wadded up on the ground there, so you're going to pull it tight. So you're going, here's the flagpole over here, by the way. You see it? And the rope's just hanging. I'm going to take that rope and walk backwards with it until it's as tight as it can be. So at some point here, it's tight. Okay? So we've made a perfect triangle. Because, and it's also a right triangle because this floor is right angle with the flagpole, right? So the rope reaches a point on the ground 18 feet from the base of the pole. You remember where the pole is, right? All right. Find the height of the pole to the nearest tenth of a foot. That means Chris is going to have to climb the pole with a measuring stick and come down. No, we're not going to do it that way. We're too lazy. Yeah, Chris may not be, but yeah, we are. Okay, we're going to find an easier way to do this. How do you think we're going to do that? Draw a picture. All right. I want to give bonus points, but I don't do that. Okay. Way to go. That'll be 3 attaboys for you. All right. Good. Okay. So here is your picture. There's our flagpole. Here's our floor. And here is 18 feet from the flagpole. Okay. Now, we also know what other measurement? The 50-foot rope. So here's your 50-foot rope. Okay? And what does Pythagorean theorem tell us? That a squared plus b squared is equal to c squared. So we would have to square this and square that, right? Except I may not want to call it a. What you want to name the height of the pole? Is a okay, or you want something else? A's fine, okay. You could call it H. I'd like to call it that, but that's fine. Okay. So anyway, a squared is equal to what then? Or how do you want to write that? I'll let you tell me what to write next. I won't put any words in your... How would you write it? Okay, he's saying 50 squared is equal to a squared 18 squared. Very good. Right? Now, I can do this one in my head. That is 2500 is equal to a squared plus. Now, 18 squared I can almost do in my head. Let me think if I can. That's 2 times 9 squared. 9 squared is 81, and 2 squared is 4. So 81 times 4 is 324, maybe? Okay, y'all are quick. Okay, I'm sort of slow. I'm old. Huh? Well, those are slow, aren't they? Okay. Now what do we do? Subtract 324 from both sides. And that gives you 2176. Am I right? Equal to a squared. See, those will slow you down, but see if I'm right. Okay. Huh? Did I get it right? Okay. And then what do we do there? I don't care what a squared is. I want to know how high is that flagpole. And Chris does too before he climbs it, okay? So how are we going to do that? Take a square root of both sides. And what does that give you? A is equal to, now when I take a square root of both sides, what do I normally do? Plus or minus, and what's the square root of 2176? You can do this one on the calculator because I'm not about to do it in my head. Well, now what good is that calculator, okay? Okay. I can show you how to do it. Oh, you got a phone. You may not be able to do it anyway. Who cares about those? Okay, no, I don't know how to do it on the phone either. You got a calculator, don't you? Or do you? Is that a phone? You? Okay. Phone too. Anyone got a real calculator? All right. You do? Oh, you do. Fantastic. See, you're going to climb the pole anyway. Okay. What do you got? Anyone? 46.6. Maybe the book had that anyway, didn't they? And that would be feet. Okay, is that what you got? All right, good. Because they say to the nearest tenth of a foot, we got it. Okay? I don't really, they gave you that, but frankly, if you only had at most 2 digits of precision here and 2 digits here, how in the world can you get 3 digits of precision there? You really can't. I'd say 47, but they said to the nearest tenth, so I'll settle for that. Okay. So you see how that works. Okay. Again, we didn't need to know how to do that, but you got the calculators. Oh, here's how they do it. Make a sketch. Look at them. They sketched it almost as pretty as mine, didn't they? No, don't answer that. Okay. All right. And got that. They put the height as P. How silly of them. Okay. What's it? 56.7 feet. That's not what. Did y'all say that? Okay, let's see what we got. I don't know what that means at the top. And they do this, and they do that. That's what we got. They take the square root, good for them. Yeah, 46.6. What in the world is this doing at the top? I have no idea. Okay. All right, 46.6 to the nearest 10. Approximately 47 feet high. Does that make sense? Without climbing it. All right. Okay. Oops, I hear books closing. Is that a bad sign? Oh, so sorry. Okay, I know you're regretting that. All right, we're going to start next time at basically the right below example 9. We almost finished the chapter here, or the section here. Do homework exercises any of the odds 1 through 19? Okay. Well, let me take off on that for just a moment here. 1 through, let me say 1 through 11. No, 1 through 13. No, 1 through 15. No. 1 through 19. Do them all. I mean, do as many of those as you want. You can skip 21 to 25 because those, I know Jackson wants to do those because he asked about it before, but y'all don't have to if you don't want to. But he's a hard worker. Okay. So this is page 309. Do any of the odds 1 through 19. You can skip 21 through 25. Then do 27. 45. Just 27. Any of the odds here, 27, 45, 47, 51, 59. Okay, the rest of them have those irrational numbers and complex numbers. And then do number 67. And then we'll stop there and pick up the rest of them later. I'm trying not to give you any that have the radicals or complex numbers in them. I mean, they're all complex numbers or whatever. Okay, good deal. We'll see you Wednesday. Oh, one announcement I forgot to make. I'm not going to be here Thursday or Friday of this week, so don't plan to come by Thursday afternoon. I actually will be here first thing Thursday morning, but I'll be leaving after my night. Wishful thinking, huh? Okay, I called you. Yes, Yes, ma'am. I'm sorry. Yes, I did. Are y'all all coming by to see the quiz? What I'm going to do is turn off this.